Hello, today I'm going to demonstrate how to use the SPSS software to run an ANOVA test on some data. For this particular task, we are going to look at the enrollment differences between Region 1, 2, and 5 of the state data that we have. We are also going to assume the assumptions performing an ANOVA test are all met. So you'll notice that I have my statewide school data set open here. I actually went ahead and created a second data set that pulls out region 1, 2, and 5 just to make this a little easier to manipulate with the data to run our tests. So the first thing is we want to check our assumptions to do that. We want to look at the N quota and the normalcy. So to do that, we're going to analyze, then we'll go down to descriptive statistics and explore. Our dependent list is going to be our enrollment, so we'll click on enrollment, move it over. Our factor list that we're going to base this on is going to be our regions, regions 1, 2, and 5. So we'll move that over to the factor list. Then to run this particular type of test, we want to click on plots. We do not want any box plots, but we do want a histogram, and we do not need stem and leaf descriptives. We also want to see our normalcy plots with the test, so we'll select that as well. Once we have all of our options selected, we hit continue. Then we're going to hit OK to be able to run our data. And as it runs, we look at our case processing summary. Here are our N values to check our N quota to make sure it's met. If we look, Region 1 has 72 different data points, Region 2 has 66, and Region 5 has 23. As I said, we are going to assume that all assumptions are met, even though particular N is not, as it's 23, as all N values have to be 30 or above to really truly run this test. So since we're assuming that those are 30 and above, we'll scroll on down to look at the test for normalcy. To look at that, we look at the significance of our Sharperio and Wilk over here in this last column. You'll notice that regions 1 and 2 show less than 0.001 significance. We're really looking at a 0.05 or larger to make sure that its normalcy of the data is distributed. So we notice that region 5 has a 0.08, which is larger than 0.05, whereas regions 1 and 2 are not. Since we're assuming the assumptions are all met again, we will move on to the next step in testing the homogeneous of the variances. To do that, we're going to go back up to analysis again. We'll scroll down here to compare means. And then since we're doing an ANOVA test, we're going to go to one-way ANOVA. Select it. Our dependent list, once again, is our enrollment of regions 1, 2, and 5. Our factor that we're basing that on is the regions of 1, 2, and 5. We then want to click on the post hoc, and we would typically use turnkey. That's if all the N values are the same. Since they're not, or if they're not, you would use the SIDEC. So we're going to select SIDEC since we had different N values. Like I said, turnkey you would use if all the N values were the same. We then hit continue. We go to options, and we want to test the statistics on the homogeneity of variance test. We then hit continue, and we hit OK to run the data again. And let's see, where are we at? I may have lost where I was at in my data file here. I may have to, there we go. There's our test that we just ran. I guess I didn't need to scroll back up to the top. So we will look at the mean to start with. It is less than 0.001. Typically, we would want to see that at 0.05 or above to know that the means are all homogeneous. Since it's not, we will move on forward, even though it's not, because we're assuming that all assumptions are met. So we scroll down and look at the ANOVA. The significance there between the groups is 0.055. This, in turn, is larger than 0.05, so there we assume with that data analysis that, in fact, there is no significant difference between the groups of data that we have of region 1, 2, and 5's enrollment. Therefore, we're complete and we do not need to go any further. If that in fact was less than 0.05, we would go on down to look at the post hoc and find out where our regions were significantly different amongst each other. That concludes this demonstration. Hopefully you learn a little bit, as I did while developing and demonstrating this task. Thank you.